We're ready to develop the last precursor to talking about one of the central ideas of algebra. The idea we're going to talk about right now is the idea of a relation. And at its most basic, we can think of a relation as a set of ordered pairs. If the pair xy is an element of a relation R, we say that x is related to y, and we write xry. Now, what concept are we trying to convey here? We think of relations as expressing a relationship between numbers. And we think of the notation xry as paralleling things like x is less than y. So that r in the middle is just describing the relationship. X has relationship r to y. So if R is the relation consisting of just these 5 ordered pairs here, then we can write xry for any pair of numbers that's in one of these ordered pairs. So 2, 4 is one of these ordered pairs, so we say 2r4. Negative 4, 0 is one of these ordered pairs, so we say negative 4r0. 1, negative 1 is one of these ordered pairs, so we say 1r negative 1. And we think of that as a statement, right? So that's a statement that a pair is in our relation. We can think of these statements as true statements or false statements. So, for example, the statement 3r5, that corresponds to the pair 3, 5, which, looking at r, that pair is not an element. So the statement 3r5 is false. Negative 3r5, that corresponds to the pair negative 3, 5. And we see that that is in R. So that statement is true. Negative 2r0, that corresponds to the pair negative 2, 0. Now 0, negative 2 is in R, but the order matters. So negative 2 is not related to 0. Again, this statement is false. We think of a relation, a set of ordered pairs, as having some set of first entries and some set of second entries. For a relation, the set of all the first entries is called the domain, and the set of all the second entries is called the range. So for this relation R again, its domain consists of all of these first entries. So we have a 2, a negative 3, a negative 4, a 1, and a 0. And then its range consists of all the second entries. So we have a 4, we have a 5, we have a 0, we have a negative 1, we have a negative 2. The domain consists of all the first entries. The range consists of all the second entries. And notice when we write sets, the order doesn't matter. I've just written them down in the order that I see them. Let's see another relation. So the relation S, again, the domain consists of all the first entries. So we have a 0, and then we have a 0 a couple more times. We don't need to repeat that. We have a 1, then we have another 1, we have a 2, and finally we have a 3. In the range, we have a 1, We have a 2, we have a 3, we have another 2, we don't need to repeat that, another 3, another 3, another 3. So for the relation S, the domain consists of the numbers 0, 1, and 2, and the range consists of the numbers 1, 2, and 3. Now notice, when an element of a set is repeated, we only list it once. And so the range and domain may have fewer elements than the relation. They can have different numbers of elements than each other. They can have fewer elements than the entire relation. They can never have more elements.